The producers and distributors of Tech AV technical training aids welcome you to this training program on the subject of basic hydraulic systems maintenance. Hydraulic machinery is used in a wide variety of applications, such as in materials handling equipment, production presses, earth-moving equipment, and a host of other machinery. The principles upon which hydraulic equipment operate and the procedures involved in maintenance will be similar for all systems. Let us begin as we first take a look at the fundamentals of fluid power and hydraulic systems. Fluid power is the term used to describe the transmission of energy or work through a fluid medium instead of through mechanical drives. This fact can be demonstrated using simple medical syringes, plastic tubing, and some colored water. With the two syringes connected via the tubing, the basic principle of hydraulic action can be demonstrated. As you can see, when one of the plungers is forced down, the opposite plunger moves. Hydraulic systems, based upon the principles that we have just discussed, are capable of producing extremely powerful forces. Bearing these points in mind, let us take a look at the makeup of a typical hydraulic system. Any hydraulic system will comprise three main sections, namely, a power pack that is responsible for the oil flow through a system, actuators which convert. For purposes of demonstration and explanation, we shall feature a unit of the type found in many light industrial applications. The system comprises a power pack, a double-acting cylinder, and a four-way open center control valve into which the system's relief valve has been incorporated. Let us first take a closer look at the power pack. The dominant feature is the reservoir, most usually called the tank. The main functions of the tank are to contain the system's oil, to cool the oil, and to support items such as the pump and drive motor. Oil is drawn out of the tank through the suction line by the pump. Oil re-enters the tank via the return line, having flowed through the system. The suction line and the return line are kept separated, most usually with a baffle plate. The baffle effectively slows the internal flow of the returning oil inside the tank, giving it time to cool before it reaches the pump suction inlet. Featured on the tank is an oil level indicator, combined with a thermometer. Tanks are designed to contain large amounts of oil, much more than the circuit requires, primarily to improve cooling. Much heat is generated as the oil flows through the system and is carried back to the tank. The biggest enemy of a hydraulic system is dirt. When particles of dirt enter internal components, such as direction control valves, relief valves, and such like, major problems can occur. A system will generally be protected from the damage that dirt can cause by fitting strainers and filters. If you've ever traveled on a gravel road, then you'll know what dust looks like. Dust has a way of getting onto every surrounding surface and into every opening or gap. Dust of this nature is made up of very fine particles of grit, which, if seen under high magnification, would appear as tiny stones or rocks. And to the inside of a hydraulic system, this is exactly what they are. The air around manufacturing plants, factories, or construction sites contains dust of some kind or another. Dust will always settle on it. Hydraulic oil has four main purposes, namely, to act as the power transmitting medium, to lubricate moving parts, to seal small clearances between parts, and to remove heat from the system. Hydraulic oil must not be confused with other oils, such as engine oil. It is very important that we don't accidentally confuse or mix one type with another within a system. Manufacturers of hydraulic systems will usually specify the type and grade of oil to be used in their equipment. Always check this specification before you attempt to replenish or change the oil. Oil may be packaged in 210-litre drums or in 20-litre drums. The manufacturer's label on the packaging will provide details of the oil such as viscosity and grade. Hydraulic oil has a low viscosity, which means that it is normally thin or runny. You will need to ask your supervisor to explain the specific viscosity rating, the grade, and the make of oil used by your company on various machines. The most important maintenance point about oil is that you keep it. Filters and strainers will eventually become clogged as they trap more and more dirt particles. For this reason, they will require some attention in the form of cleaning, or more commonly, renewal. Replacing or servicing strainers and filters are not difficult tasks, but there are some points that you should be aware of. Safety is the first point. It is never a good idea to work on a live machine. So, before you start doing any task on a system, make sure that it has been isolated. Next, keep in mind that hydraulic oil can be extremely hot after a system has been operating. For this reason, it is wise to allow time for the oil to cool before you start working on it. Use appropriate gloves if, for some reason, you are forced to work on the unit whilst it is still hot. For purposes of demonstration, let us look at the various tube and hose connections. As you will observe, even on our very basic demonstration unit, there are several connections. Every connection presents the potential for a leak. A loose connection is the usual reason for an oil leak at a joint. When tightening a union connector nut, use 2 spanners, one to support the adapter connector and the other to provide the turning force. In this way, you will avoid twisting the tube or hose. Use only spanners that fit neatly across the flats of a nut. If the spanner size is too large, it may slip when force is applied, resulting in injury for you and damage to the fitting. Adjustable spanners may be used when set spanners are not available. Make sure that the jaw opening is set correctly over the flats of the nut. Here are some safety precautions that you must adhere to when working on hydraulic lines. Do not work on connections when the machinery is operating. Make sure that there is no load on the system. Lower any raised load before stopping the machinery. Check the pressure gauge. Hydraulic power systems do not present many problems. If the oil is kept at the correct level, filters cleaned or replaced when specified, and the tank kept clean, then the system will generally provide years of trouble-free service. When a fault does show up in a system, you will not, at this stage, be expected to repair anything, but you will be expected to provide an accurate and intelligent report to a supervisor. The first step is simply to observe the problem. You should be able to describe the symptom in terms of. Those of us who will soon be involved in working on hydraulic systems should be able to read a basic symbolic circuit diagram. A circuit diagram is essentially a plan of a system, indicating the various components, connections, and other details of the system. We use circuit diagrams when, for example, we're trying to trace problems. Our demonstration unit is a very basic system, which, if drawn as a circuit diagram, would appear like this. Let us build up this diagram step by step. There are essentially 4 major visible components that We look forward to having you participate in other Tech AV modules designed to help you improve your knowledge and skills in technical aspects.